Okay, welcome once again. It's actually exactly a month now, and I hope you guys are taking inventory to see if you're actually learning something and to see where we can help if things are not actually going the way you envisioned it. But for the most part, I believe that we are all learning one thing or the other, and we will just continue to improve or to build on things that we've been learning so that we would all be able to achieve the goal of becoming application developers, um, essentially, but using database programming as our inroad into becoming software or application developers. So I congratulate you for sticking to it for a month and going through all the course materials. I will still encourage you to continue doing that. So without further ado, let's just jump right into what we have today. All right, today we will be starting up with a quiz. Yep, it's going to be a test of what we have been doing for 3/4 of the time we've spent together. This quiz is going to, kind of gauge where we are, um, how we're doing. It's something that I want you to actually take as seriously as you can. The caveat here is I want you to submit this as a script, meaning that every one of you would have to open up your management studio, open up a new query window, and then you will use comments because that's another thing that I want you to practice. You are going to use comments to answer this question. So let me give you an example. By now, you should know what a script is. I shouldn't be explaining what a script is. Okay, so I need your answers as scripts. Now, you also should know what comments are. So, depending on which type of comments you want to use, if you want to use inline comments, so this is what I'm expecting, number one, and then you state what question you are answering. You state what question it is, right? And then you will answer, you will place your answer, okay? And then the answer, if I can spell today, all right, the answer goes here. And then the question, the second question, the same thing. And then once you are done, what I would like you to do is let's agree on a naming convention. Um, so right now a you should have a directory on your personal computer, maybe on your C drive documents, my documents. I believe you should have a a directory. When I say directory, I mean a folder. That's all I mean, a folder. Okay? You should have a folder. Let's say this is my document. This is what I assume right now. Let's say this is my document. All right. Inside my document, you should have a folder for this program. Okay. Whatever name you've given the program, maybe let's say you call the program database development. Okay. Database dev. This is inside my document. This is my document folder. Inside my document, you have this database development folder. And then inside database development, you should have another folder called scripts. Okay, and it's inside script that that I um, that I expect you to save all your scripts. Now, the naming convention that we are going to use for this first script is you would use your name underscore the um, year, month, date, all right, underscore date, underscore quiz dot SQL. That should dot SQL. You remember last week we talked about the file extension dot SQL. Okay, so for in my case, I would name mine. This is what my script will be saved as 2019 0409 underscore quiz dot SQL. Okay, so when you are saving your script, when you are done with it, this is the naming convention that I would expect you to give your script. Okay, and then just send it. Just attach this as an attachment. Once you save it, okay, attach it as an attachment and send it to the Illview Group Inc. at gmail.com. So that's how I want you to go ahead and um, get the answers to these quiz questions. If you have any question, go ahead and ask me. However, it's timed. It's just to gauge where you are and how you can quickly respond. Most of the questions that I've written out were taken from interview questions. So just go ahead and attempt it. I'm going to time. It's going to be a 15 minutes. It's not going to be a 10 minutes. It's going to be 15 minutes. All right, it's going to be 15 minutes, and I'll give you ample time to work on it. The 15 minutes does not include you sending it to me. So just go ahead, finish up in 15 minutes. However, you can get through as much as you can, right? The reason I'm asking you to state the question, to copy the question, just copy the question and paste it, right? The reason I'm saying that is if you decide not to follow it in order, I would know what question you are answering. Okay, so just go through as many as you can in the 15 minutes time limit that you have. And if you have any question, go ahead and ask me. Okay, so let's give it a try. All right. All right. So feedback. What do you think? What is your impression? Were all fair questions? Yes, no, maybe. What is your impression about the quiz? I need feedback. Do you think they were fair questions? Do you think there were things that probably if you had more time you would be able to go to town? What do you think? So what I'm saying in essence is answering the question itself is just about 50% of of the grade, right, that you can get in this particular quiz, right? I'm looking for how you can navigate the management studio, what, how you can use comments, and also the naming convention that we agreed on, how you can follow the naming convention and be able to save file using that naming convention and send it. So um, For the questions, you can always come back, you can always answer the questions, but the reason it's timed and I wanted you to submit it during the class is to look for all those other things. So I think you'll be in good shape if you attempted the question, saved and sent it to me, and then you followed the naming convention. So I think you should be good with that. For the question itself, just go over the question again in your own time. Make sure that you do understand what the question says and be able to answer it. Okay, any other feedback? All right, so with the quiz behind us, let's just go ahead to today's business. Right, we'll start by doing a little bit of a review of what we've done so far as per relational databases. Right now, you know what relational databases are, and then you know what they are comprised of, entities, and these entities began as the conceptual model objects that we started with, and they're actually related. The entities, they become the tables as we go on in developing the solution that we started um, in the requirement phase. The entities, they become the tables, and then they have attributes. We said these attributes are the properties of the entities. In a case of a customer, they have a first name, they have a last name. For a product, they have a name and a list price, and we went ahead and talked about how we model these database elements, you know, in which when the entities become the tables, the attributes become the column. We've been able to go ahead and progress from getting the attributes to knowing the properties of those attributes, which includes the name, the data type, and the nullability. And then we decided on what's the unique identifier of the table is, which becomes our primary keys. But because the tables, they relate to each other, then in that case we will need to know how each table relates to another table, in which we talk about foreign key constraints, whereby you would see that um, one entity would relate to another entity by a primary key foreign key relationship. So we are talking about a situation where we have an entity that becomes a table, and in that one entity, like the customer entity that we see here, in that entity we will decide on a primary key for that entity, in this case the customer ID, and the sole purpose of the primary key is to uniquely identify each row, right? But this entity is not existing in isolation, it's related to another table, it's related to another entity. And we can see in the case of the sales order header and the customer entities, they are related to each other. And in order to enforce that relationship, we will need to know what the primary key is and what the foreign key is in the table that they relate to, such that from the customer to the sales order header, you would see that the primary key in the customer table becomes the foreign key in the related table, which is the sales order header, such that that primary key can be used to track the sales that the customer is involved in. You would see that the customer ID 1 actually purchased um, an order ID of 1 in January 1st, 2015. Okay, now from there you can see that the sales order also relates to the sales order detail via a primary key foreign key relationship, where the order ID of the sales order header is related to the order ID of the sales order detail, right? In the sales order detail, the primary key is a composite key, meaning that it is made up of the order ID and the line item number. All right, a composite key being a primary key that has more than one constituent column. All right, that is a composite key. All right, so you begin to see that all we have been learning so far have their real life implication when it comes to making sure that our solution actually does what we want it to do, meaning it will satisfy the requirements. Okay, so this is just a run down review of everything we've done, and we should be comfortable with these terminologies that I've used so far, such that if somebody asks you what the primary key is, what the foreign key is, you will not only be able to just rattle it out, you'll be able to visualize it in your mind how this is, what this is, and why it is important. Okay, why we need to know what the customer ID is in the sales order header table, right? And that while the customer ID is only mandatory to be unique in the primary key table, right? It is not a requirement that it is unique in the foreign key, because the foreign key is the many side of the relationship. The primary key is the one side. Okay, so for if you want to talk about the cardinality of the customer and the sales order header table, it has a one to many, the customer being the one side and the sales order header being the many side, right? You should be able to be comfortable to describe and discuss these things, not only on a level where you know this it's just memorizing it, but being able to picture what you are saying exactly, right? This would help a lot when you begin to write the code that will satisfy things that you set out to do. All right, so having done that brief summary, you go to how these relationships, the relationships that we've been talking about so far, how are they implemented, right? In this diagram, you see three different entities: the product subcategory, and then the product category. And you will see that the product category and the product subcategory has a one to many cardinality, such that you would expect the primary key, the one that has a red border, the primary key in the product category table. Again, the product category is on the one side of this relationship. You can see by the key. You can actually see it by the key symbol. That is the one side of this relationship. This is the one side, right? And then for the many side, you see it with, like I said last week, an 8 that is lying on its side. Okay, some say it's the infinity symbol, but I say that it looks like an 8 that is lying on its side. Okay, so that's the many side. This is the many side, and this is the one side, right? So we expect that the one side is the one that will carry the primary key, and so the product category ID is the primary key in the product category table. But when it comes to the product subcategory, right, then the product category ID becomes the foreign key, and you can see that's why it's shaded blue, because the product subcategory entity has its own primary key, which is the product subcategory ID, right? Don't confuse that. The the reason that the product category ID is the primary key of this table is because every entity must have a column that uniquely identifies each row. Okay, you are at that point you are enforcing what we call entity. You are enforcing an entity constraint. Okay, you will hear people say entity constraint. Now, the entity constraint is nothing but the primary key. That's the primary key because what it does is on an entity level, remember the table is derived from your entity. So on an entity level, it makes sure that each row is unique, right? That's why the primary key enforces an entity constraint, right? Now, each entity has its own primary key because every entity must have a column that uniquely identifies the row. But to be able to enforce referential integrity, right? To be able to enforce referential referential from the word reference, referential integrity, meaning that if a product category can have more than one product subcategory, to be able to enforce that referential integrity, the integrity of the data that typifies the relationship between the two entities. All right, something must enforce the relationship between these two entities, product category and product subcategory. We must have a concept that enforces how they are referencing each other. The referential integrity must be enforced, and that is where you have the foreign key. So the referential integrity is enforced by the foreign key. All right, you would hear people ask you, or talk about both the entity level constraint and then the referential integrity. Just know that they are talking about the primary key and the foreign key respectively. So to be able to have referential integrity between the product category and the product subcategory, we would have to make this primary key column, we would have to introduce it into the many side of the entity that table relates to. All right, so it is because we have that foreign key relationship in the referenced table, that is how we can enforce that the relationship between the two tables is actually enforced. So you have the product category ID being the foreign key in the product subcategory table. And then if you go from the product subcategory table to the product table, you would see again that you have a one-to-many cardinality, which is the same thing. So you would expect that the product subcategory ID, which is the primary key in the product subcategory table, becomes a foreign key in the product table. All right, so this is how the integrity of the data is enforced via primary keys and foreign keys. And then you will see that it's a natural, it's actually a natural relationship, because from your business rules you will begin to see how the objects or the entities relate, and then when you are now implementing your database, you need to enforce that type of relationship. All right, any question? Any question before we move on? Okay, if there are no questions, let's just move on. So now that we are able to build the database, we know about all the constraints that we need to be able to enforce the business rules. The database is in place, the tables are in place. We've placed our primary keys, foreign keys, relationship. Now we will need to begin to work with the database itself. Okay, and before we can work with the database, we need to understand what we call the fully qualified name. All right, so a database, right? A database is an object on the server. Okay, now from now on, you need to be familiar with the concept of a parent-child relationship. All right. So from now on in your programming career, you need to be familiar with a parent-child relationship, right? Such that every object in on the server, on the database server that you are working on, every object has a fully qualified name. Okay, the fully qualified name ensures that there is no ambiguity. Okay, so what the fully qualified name ensures is that we do not have a situation where we have any ambiguity. So that if I call object A, right, or I call object B, as long as I use their fully qualified name, right, I would not be calling, two objects would not think that I'm calling them at the same time as long as I use the fully qualified name. Okay, so um, an example that I can use is if, let's say, in a class you have two students that are called John, right, or any other name. You have two students in a class that are called John, right? If the teacher just goes ahead and says John, now there's confusion about which John they are talking about. But the moment the person trying to call a John calls them by their last name, maybe John Barnes or John Snow, right? As long as you introduce the concept of the last name, then there is no longer an ambiguity as to which John you are trying to refer to. And this is the same thing that the fully qualified name does, right? It gives you a situation where you are calling an object on the server with its fully qualified name, thereby removing um, any likelihood of ambiguity. Okay, so when we talk about the fully qualified name, what do we mean, right? Now, again, remember that every object on the server, everything on the server is an object, especially or including the server itself, right? From now on, you know, you will begin to hear about object oriented programming. Okay, this is a programming construct, right? It's a programming construct that is different from procedural programming that has been done, prior to the object-oriented programming. Okay, so in an object-oriented programming environment, everything is an object. Okay, so when we now come to the database world, we are saying that every object in the server, including the server itself, is an object. Okay, so if you are talking about the fully qualified name of any object, right, we talk about the four-part name, the four-part name. If you use the four-part name of any object, you are guaranteed to have no ambiguity. And what is this four-part name? You start by stating the server name, okay? You start by stating the server name followed by a dot, okay? This dot is what we refer to as the member operator. All right, and all it does is that, all right, what's to the right of the dot is a descendant of what is on the left, right? That's what the dot is just saying, that the whatever you are seeing on the right is a member of what's on the left. Remember, I was talking about a parent-child relationship. So in this case, what we have is a parent dot child. That's what I'm trying to say. A parent dot child, right? So if you start with the server dot database dot schema dot object name, that is the four-part name, which is the fully qualified name of any object on the database server. All right. So if we have a server, let's say we have a server called YOLO PC, right? And on that server, we want to refer to a customer table. We want to refer to the customer table. Remember, the four-part name is server.database.schema.object name. All right. So if we are talking about a YOLO PC server, right? The database server is called YOLO PC. Then to get to the customer table in the AdventureWorks database, all we need to do is to say YOLO PC dot AdventureWorks LT 2017 dot sales LT dot customer, meaning that the server name is the YOLO PC, the database name is AdventureWorks LT 2017, the schema name is sales LT, and then the object's name is the customer. Okay. If you state the name of any object, the object in this case being the customer table, right? This is a table. You can have so many objects. This is a table, right? You can have views, you can have stored procedure, you can have function. We will talk about all these objects subsequently in the class, but for right now, we are trying to refer to a table, right? So we are saying that to make sure there is no ambiguity, right? If we use this naming convention, YOLO PC.AdventureWorksLT 2017.SalesLT.customer, then we will be able to refer to just this customer table and this customer table only. Any question? Okay, so in the same vein, right, most of the time your four-part name would not be necessary, right? Most of the time you'll be able to get by with just the three-part name, all right? And then you would have already guessed what the three-part name is. The three-part name is just the database dot schema dot object name. Okay, so it's a given that before you can access any object, you are already on the server, right? So most times you can exclude the server name and then it gives you a three-part name. So we could have gotten by saying AdventureWorks LT 2017.sales LT.customer. We could have gotten by saying that. And then sometimes you can actually even use the two-part name. All right, and the two-part name is just your schema name dot the object name. So your sales LT dot customer, as long as you have changed the database context to point to the particular database you are trying to work on. Okay, such that if you issue saleslt.customer on a database that does not contain that table, you would get an error. Okay, so if you are going to use the two-part name, you must make sure that you have changed the database context to that database you want to work with. Two ways you can do that. You can do the use. You can do the use database keyword that we have been talking about, like use AdventureWorks LT 2017, or you can go to the database context drop down and change the database context that way. You should be familiar with doing both right now, but we will actually talk about it as we go on in this class. Okay, so now we know what the fully qualified name is. We know that if we want to call, or if we want to refer to an object, a table being one type of object, if we want to refer to an object, if we use the four-part name, right, of the server.database.schema.object name, we can be able to get to that object. But since we are on a particular server to be able to even talk about getting to an object, we can drop the server name and just use the three-part name, which consists of the database dot the schema dot the object name, right? But at the same time, we can use the two-part name, the schema name dot the object name. Okay, so up till this point, we know what the server is, we know what the database is, but what is this schema that we keep talking about? And actually, we know what the object is. We said the object's name could be a table name, could be a view name, could be a stored procedure name. So that's clear. So what's this schema that we keep talking about? What does it mean, and what does it do? Okay, so let's talk about schemas, right? Think about schemas as just buckets, right? Think about them as buckets that you can actually, or let's say a container that you can actually use to wall group of related things together. Okay, so you have a group of related things, and those things you want to just keep them in their own space. So think about a schema as that space that you want to keep objects that are related to each other. So we say that schemas are namespaces, right? The word namespace just refers to like an area or a container or a bucket where you can keep things that are related to each other. So just have that concept in your mind whenever you hear about schemas. Okay, and then we talked about fully qualified name, which you already know. So what are the use of this schema that we talk about, right? um, let's say in a situation where you have a database design where there are departments, right? Like in this particular example, you have the sales department and then you have the production department. Both the production department and the sales department have a concept of an order. Okay, so the sales department have their own concept of an order, right? And the production department, they have their own concept of an order, right? The sales department, order to them might mean that the order that is being placed by a customer. In the production department, order to them might be the order that is being placed by the sales department. Okay, so although both of them have that concept of an order, it is two distinct entities. I hope you understand that, right? Although they both have the concept of an order, right? It is separate and it is distinct from each other. Okay, so if you were tasked with developing a database solution for the company like this, right? Um, one one thing that might come to your mind is to have like sales order table and then production order table, right? That's one way that might come to your mind. One thing that might come to your mind, but you want to develop the database with in the same way that the current operation is going on, right? So you don't want to introduce new nomenclature. You don't want to introduce new language, right? The sales department call their order. The production department call their order, right? You don't want to introduce production order or sales order. In this type of situation, you use a schema. Okay, now think about it. If I now say, um, get me the list of rows in the order table, the first question you're going to ask me is which order table, right? That is where the schema comes in, right? If you group all the sales entity in the sales schema and you group all the production entity in the production schema, then you will be able to avoid that ambiguity that we had a few seconds ago, such that if you now say get me all the rows in the sales dot order table, schema name dot object name, right? If you say give me all the rows from the sales dot order table, then it is not ambiguous with give me all the rows from the production dot order table. Okay, you begin to see how schemas help to resolve issues when there are name clashes, right? A schema would help you to actually resolve this issue. Okay, so just think about a schema as a logical compartment, like a container where you can store all related objects in. In this case, we are storing all the sales entities in the sales schema, and then we are storing all the production entity in the production schema. Okay, when you don't state a schema. Up till now, we've not had the concept of a schema. We have just created our databases. We have been creating our tables in the database, right? When you don't have the concept of a schema, if you don't specify any schema, right, and you create objects in your database, there is a default schema that um, the database engine provide. The default schema is called DBO. Okay, you would have seen that DBO dot object, right, dot customer or dot sales, right, that you've been seeing when you've been creating your own table up till now. That DBO is the default schema that is provided by the database engine. So the concept of the schema is a best practice. Okay, if you don't provide one will be provided for you and it will be called DBO. But if you have a situation where you need to group related entities together, then you can now create your own schema and call it anything you need to call it. In this particular situation, we have the sales schema and then we have the production schema. Okay, any question? All right, so now that we are able to call an object, we now know the name of an object, how we can refer to an object. Because if we have a table and we want to get data back from the table, we've created a table, we've inserted data into the table, and now we want to get the data back. We need to call the table by its name. So now you know how to call an object, you know the fully qualified name, you know the three-part name, you know the two-part name, right? The standard is for you to use the two-part name, right? It's the it's always good to use at least the two-part name. Okay, so you know all this. So now let's start trying to retrieve data from our database. Okay, let's start the process of querying data from our database. All right, so now last week we talked about queries. I won't go in depth into that, but we talked about queries in our last class, and we said queries are the result of a select statement. So if we want to retrieve data from the database, we have to issue a select statement. Okay, now the select statement in its simplest form, um, yes, in its simplest form, when you are talking about data in a table, is first to issue the keyword select, right? Issue the keyword select, and what the select needs is a list of the columns, right? Now, when you are reading, this is a syntax. Anytime you see a code like this, is just a is just what the syntax rule is, right? So if you are reading a syntax rule, anything that is in a square bracket is what we call optional. All right, they are all, if you see anything in a square bracket, it's optional, so it's not required, right? Eventually you get into the reasons why you should be using any of this, right? So whenever you are reading a syntax rule like this, the first thing you note is the everything that is in a square bracket is optional. If you see a pipe, this vertical line is what we call a pipe, right? It's called a pipe, P-I-P-E, right? If you see a pipe, that means that it's either this or this. It's either one of what is in the left and right of the pipe, right? So it could be all, or it could be distinct. It could never be all distinct, right? So if you see a pipe, you note that it's either one the of what is written on the two sides of the pipe, right? But for this case, it's all in square brackets, so it's even optional. So if you don't add any of this, your select statement is still going to work. But what's not optional is the select list, right? So you write your select and then you add your select list. The select list for our for our discussion right now, you can say that the select list is your column list. Okay? Column list that is comma separated. Again, note that we are learning a programming language, okay? If we are going to speak the language, we must know the syntax rules, right? In the same way, if you are learning English, you need to know how to stitch the words together to form sentences, right? This is the same thing we are doing. Stitching the words together to form sentences is actually following some syntax rules, right? So in this case, we're trying to see what are the syntax rules that can allow us to retrieve data from the database. Hold on one second. So our goal is to be able to retrieve data from a database, right? Retrieve data from a table at this point, right? So what is the rule, right? What are the syntax rules that we need to have to be able to stitch the words of this programming language, T-SQL, together to be able to form a sentence that can retrieve data from our database. Okay, so we say we issue the select statement, and then mandatorily we have to issue the select list. We said that the select list is a comma separated column list. So the columns, remember, the columns of the table that we are trying to retrieve stuff from, we would have to state which column we want to retrieve. And if we are retrieving more than one column, they must be separated with a comma. All right. Now, after that, we will come to another clause, the from clause. So we issue the select clause, clause as in clause, not Santa Claus, this clause, right? We issue the select clause, then we tell the select clause what column that we want it to retrieve. If it's more than one, we separate it with a comma, and then we now issue the from clause also, right? So the from clause is what will tell us which table we need to add, we need to pull data from. So while the select list introduces the columns, the from clause tells us what the table name is, what we call the data source, right? What is the source? That is what the from clause would tell us. Okay, so the select list specifies the columns to be returned. The from specifies the table from which the columns are to be returned. Okay, so if we note that this is the rule for us to retrieve data, we need the select clause with the column lists, comma separated, and then the from clause with the table name. If we note that, let's talk about the select list. Okay, now the select list, which is the list of columns in the table, comma separated, right, is expected to be separated with commas, right? Now, if you are trying to retrieve all the columns in the table, then there is a shortcut. So instead of writing each of the column names of the table in the select list, right, you can use the asterisk. We've been using this for a while now. You can use the asterisk if you are going to retrieve all the columns. However, if you don't want to retrieve all the columns and you want to retrieve specific columns, then you can use the comma separated list of columns, right? Now, let's go see what this looks like. So, in a basic query example, if you are retrieving all the columns, you write your select, again the asterisk. The asterisk is just above the 8 on your keyboard, so shift 8, right? Shift 8 would give you the asterisk, select, asterisk, from, right? You see that after the from, we have the two-part name for the table, production.product. So if we issued this command in the query window and we hit execute, this will retrieve all the columns from the product table that is in the production schema. So what we are telling the database engine to do is get me all the column from the product table that is in the production schema. If we were going to work with specific columns, if we don't need all the columns in the product table and we only need the name and the list price column, we state select name, comma, list price from production.product. Okay? Now, there are times when we don't issue the name of the columns in the select list, but we issue what we call expressions. So you're not only limited to the names of the columns in a table, sometimes you will actually use expressions, okay? Such that in a case where you want to get the name and the list price multiplied by 0.9%, okay, you can use this expression. This is an example of an expression. Okay, it's going to evaluate into a, in this case it's going to evaluate into one value, right? We call that any statement that evaluates into a value is called an expression. All right, so in the case where we need to use an expression, we can add it into the select list, right? An expression, once it evaluates, we can now alias it by introducing the as. Okay, introducing the as statement. Now, what we are saying is take the name column, alias it as product, then evaluate this expression, alias it as sale price from the same table. Okay, we will look at this in Management Studio in a minute. Okay, in fact, let's go ahead and just look at that right now before we get back to what we're doing. So um, let me take this off. Okay, so you should be able to, let me put that off too. Let me increase this. So in a situation where you are told to retrieve specified columns from the customer table, okay? Now, before we even go ahead and do this, right? One thing I need to tell you is any query that you are going to write, okay? You should take a moment to think about what you are trying to achieve. Do not just rush to write queries in your in Management Studio. Let's say you were told to retrieve 3 columns from, let's say, the product table. At the very least, before you even open Management Studio at all, let's say they tell you the question, because every query that you are going to write would answer a particular question. All queries answer a particular question, and the scenario is you are probably working for an organization, and then maybe they need to know how many products they currently carry, right? Or what are the names of the products that they carry, right? So you can have that query in form of that question. What are the names of the products we currently carry? So this is going to be how your business user will phrase any question to you as a database developer. All right, and if they phrase this to you, you would have to write a query that targets a database to retrieve this answer, to retrieve the answer to this question for them. Okay, so what I'm saying is when you get the question for the query, do not rush to write your code immediately. Take time to design the um, the query, right? Take some time. Think about that query as your software that you are going to produce, right? The answer to the query is your software that you are going to produce, okay? And if the answer to the query is your software, there is a methodology when you are trying to create software. If you remember the methodology, it's called the SDLC, okay? So if the answer to the query is the software you are producing for this time, right? Then there's a methodology you have to follow whenever you are creating a software, and it's called the SDLC. We have gone through it, okay? So if we take the question as the requirement, then to be able to build this software successfully, we should not rush to construction. We should take some time to plan or to design what we are trying to write. So our design can be as simple as stating one, where is the data source? And if we say data source, what we mean is where is the table that we will get this stuff from, right? And two, do I include all columns or specific columns? Okay, so even if your design is as simple as this, then it behooves you to be able to take that time to actually plan out what you are doing, right? And then from your plan, what you will get is what we call pseudocode. All right, a pseudocode is nothing but just a near English interpretation of the code you are going to write. Okay, so in this case, what are the names of the products we currently carry, right? If we answer the first question, where is the data source? All right, we've been told that the data source is production.product. All right, immediately we note that, wow, this is going to be our from, because remember, our from clause carries the table, right? So we know that this is going to be our from. So do I include all columns or specific columns? In this case, all we just need is the name, right, of the product. So we are going to only deal with specific column. In this case, it's just one column. All right, so what carries the column? Select and then name. So you have a pseudocode. And it's from here that you can now go into your construction. You can see how we have methodologically followed the software development life cycle. Okay, you can see how everything works intertwined. If you can, from this state, from where you are right now, if you can imbibe this culture, if you can follow this simple rule, right? You're writing any code from your one line code to your 1,000 or 6,000 line code will be easy for you to do, right? It took a lot of time for me to get into this habit, because as software developers, especially when you are just learning a language, all you want to do is just write code, write code, write code. So I know it's difficult, right? But if you can start from now, it will be easier for you when your code becomes more complicated to be able to follow this same methodology. Okay, so in this particular situation, what we are told is retrieve some specified column from the customer table. That's the question, right? And we've been told that the columns that we are going to retrieve is the customer ID, the title, the first name, the middle name, the last name, the company name, the salesperson, email address, phone number from the customer table. So we ask ourselves the question, what is the data source? Or immediately we know the data source is in saleslt.customer, and then we've been given the select list. So it's easy for us to do. We just write our select. We write the list of our columns. Now you can see that these columns are bounded by square brackets. Okay, the square brackets are not required. Okay, what the square bracket does is, let's say the columns had a space. Maybe that was how you designed your own that's how you designed your own columns. It's a bad design, but you see this, right? You sometimes you see it. Okay, then in order to reference it, you would have to put in a square bracket, simply because this space is what tells the database engine, right, if there's a space between two particular things, is saying that this part of it and this part of it are two distinct things. Okay, so in this situation, we did not design our database this way. We actually used the correct design methodology to derive our column, so we are fine. But let's say we wanted to alias this customer ID. Remember, we talked about aliasing just a few minutes ago. If we want to alias it as, let's say, customer number, okay, in order to do this, right, there's already a space between our alias, so we can introduce a we can introduce it in square bracket. That way the database engine treats it as one unit. Okay, so just note that if you don't have this issue about spaces, right, then the square bracket is really not required. If you use it, fine, okay, but it's not required in your code. So what you should take into consideration is the column names that are separated with commas. You can see how they are separated. To be able for you to be able to um, um, for you to be able to appreciate this, you can see that if I do this, you can see that each one is separated. Each of the columns is separated by a comma. So we have this column separated by a comma by this comma from this column, separated by this comma from this column. So every column name that you are specifying must be separated by a comma. But to just make it easier on the eye, that is why most of the time if you see me writing code, I actually format it this way, right? It's still the same thing. Separate each field from the other with a comma. All right, so we have our select list here, and then we have our from clause here. The from clause carries the table, but then you will see that the from clause is a three-part name: the database dot the schema dot the table name itself. Okay, so we are using a three-part name. So if we highlight this and we hit execute, despite the fact that it's in the master database as the database context, because we are issuing a three-part name, we already specified the database, so there is no ambiguity. The database name is already specified, That means regardless of whatever is in the database context window, as long as we are specifying the database name, then it will go to that database to retrieve the particular object we are talking about. So that's one of the benefits of using a three-part name as opposed to using a two-part name. So let's run this right now. Okay, once we run it, you can see that the result set comes back, and the result set tells you all the columns that you have specified. Each one of the columns you have specified would come in as you have specified it, right? You can see that the customer ID is the first one, followed by the title, and so on and so forth. Okay, and then if you look at the status, you see that 847 rows were retrieved from the customer table. Okay, now if we want to retrieve all the um, all the columns in the customer table, remember what we need to do is just write your select and then again the asterisk from. We can borrow, since we are retrieving from the same table, we can borrow that code and just copy and paste it there. This way we are going to retrieve all the columns, and if you hover over the asterisk, you will see it gives you all the column names, right? So this is just a shortcut for all the columns. If we execute this, right, using the three-part name, you see that this time around it doesn't give us a specific set of columns, it gives us all the columns in the table, the same 847 rows. All right, any question at this spot? Any question? In the same vein, we want to retrieve specified columns from the product and the sales order detail tables, right? We want to retrieve specified columns from two tables. The first one is the product, and then the second one is the sales order detail table, right? Now we have done our we have the requirements, we've done our design, we already know that we are selecting from the product first. All right, so, and this time we are using AdventureWorks LT. Okay, we're using AdventureWorks LT, not Adventure. Um, we're using AdventureWorks LT at this point. Okay, so if we now run this code right now, if we go ahead and run this code, you will see that it gives us this error. Does anybody know why we got this error? We are using the same AdventureWorks LT that we use right here. We are using the same AdventureWorks LT. This one returned the rows we wanted to return, and then this one, by the time we executed it, said that invalid object sales lt.product. Does anybody know why that happened? So that's correct. We did not include the database name. We are only using the two-part name. Now, we can use the two-part name as long as we change the database context. Okay? So, just note which one is more convenient for you, right? Work with the three-part name and don't think about changing context, or change the context and then you can now work with the two-part name. So it just depends on what is convenient for you. All right, you can see that this returns the same as we want it to return. Okay, now in the sales order detail table, the same thing. We specify the columns, comma separated, and then we execute, and then you will now see it come back as the way we want it to. The sales order ID followed by the quantity ID followed by the product ID, then the unit price, then the line total. Okay, now in a situation where we talked about expressions, right? What if we want to um, write the same expression as we have in our deck? Okay, the expression we have here. If we want to get the name and then the sales price from the product table, okay, and we have been told that the sales price is the list price multiplied by 0.9. Okay, so our requirement in this particular situation, our requirement is to get the name and the list price, and we are getting them from production dot product. That's where we are getting them from, right? Now we've been told that the sale price, sorry, it's not the list price, we are getting the sale price. We have been told that the sale price is equal to the list price multiplied by 0.9. Okay, and we've also been told that when you retrieve the name, don't call it name, call it product name, so that whoever you are writing the report for will know exactly what it means. And then the sale price, you can just call it sale price. So how do you go ahead and write this in form of a T-SQL language to retrieve the data? Okay, so let's go back to Management Studio, and then let's just let's create some space. Okay, and as usual, we use comments, and we say we use comments. I love to use this type of comment, and then every line starts with them. You can use a multi-line comment if you want to. That will save you a whole lot of time. Okay, so the requirement is we need to see the product names and the sale price of all our products. Note that sale price is equal to list price multiplied by 0.9. All right, so we have these requirements, and then we've done our quick design. We can write out a pseudocode, and the pseudocode can be we can write the from. The pseudocode can be from production dot product, and then the select can be let's just say name comma list price multiplied by 0.9. So this is our pseudocode. We already have it, and so we go back, and then it's at this point that we now start writing the code. Okay, so we say select from it's going to be AdventureWorks 2017 dot production dot product. That's what we said we we're going to use in our pseudocode, and we are using the three-part name. The reason I like to write my from first before the select list is as soon as I have my from in place, I can use IntelliSense in the select list. So that's why most of the time, if you see me write a select statement, once I write select, I put in the from immediately, plug in the table name, so that when I come back to the select list, I can now use IntelliSense. So we are saying name. You can see name pops up. You can see name pops up in the IntelliSense. I can double click it and then I have it as that. And we said comma separated, comma, and we have list price, which also comes up, multiplied by 0.9. Don't worry, we'll talk about operators very shortly. All right, right now all I want you to focus on is aliasing, right? Aliasing column names. Okay, so if we go ahead and then we run this as it is right now, you will see that the first column that comes up is name, and then the next column that comes up says no column name. Okay, but that's not what the requirement says. The requirement says we need to see all product names and sale price. The first column is name. It should say product name, but it's name. And then the next column doesn't even have a name. Okay, so at this point, this is where we need to alias our column name. So all we just do is we come to the first column and then we just create a space after it and say the keyword as. All right, what is the alias we want to give it? Product name. Okay, but now that we have a space between our product name, you would have guessed what we're going to use: square brackets. Okay, because we have a name, we have a space between the product and the name, right? While we as programmers, we are used to Pascal casing or camel casing, the normal human being, they want spaces between their words. So if we were going to write out a report for somebody with this data, right, they will not want to see product no space name, the way you as a programmer will write it in your Pascal case. This is not how the normal human being read their report. They want to see a space. All right, and to be able to implement that space, all we just need to do is put it in square bracket. All right, so at this point, if we run it again, you will see that now the column name for the first column is product name. Okay, but the next column still does not have a column name. All right, so what do? The same thing. Come to the end, just space bar has, what do we want to call it? Sale price. Okay, sale price, same thing. It has a space. We put it, as you have guessed, in square brackets. And then when you now run this, we have now satisfied the requirement. So you see that we can alias our column names with the keyword as. Okay, and then you see that most of the sale price is 0 because the list price is probably 0, and then some of them now have valid sale prices. Okay, now if you want to know what the list price is before the sale price, then you can just introduce another column and call that list price. Okay, just to satisfy your curiosity, this is not part of the requirement, but then if you begin to see zeros in your expression, you begin to see zeros, you want to be curious what the list price is. Again, it's not part of the requirement, but just for curiosity's sake, let's see what the list price is. Well, as we have guessed, the list price for those zero sales price is 0. Okay, now once you have completed all this and you are satisfied, in order to now run this to meet the requirements, you can use a trick. If you don't want to remove any of your code, but you don't want the query engine to evaluate it, all you just need to do is to write a comment. Okay, once you comment it out, right, once you comment it out, you see immediately it changes to a green. Okay, by the time you execute it, you will see that it will be ignored because that line has been turned into a comment. So there will be times when you want to troubleshoot your code, all right, you would like to remove some um, some part of the code. You can use a comment to be able to comment that line out, all right, and that way when it's going to be evaluated, the query engine will not evaluate that commented out part. And when you are ready, or you want to see that part again, just uncomment it and you are good to go. Any question? All right, so by now you should be able to, look at the, there's a mic. Okay, thank you. So you should be able to look at um, the data model, right, of any database that you are in right now. You need to be able to look at the model. Right now, since we are still dealing with just one table, you need to practice your hand on um, writing queries that would answer a particular question. So you might look at the product table in the production schema in AdventureWorks 2017 and just ask yourself how many products are in that table, right? You can try to write a query that will answer that question. Okay, what I'm trying to get at is try your hands in writing this query. There's something that is called muscle memory, right? Once you begin to write this query, they will feel natural to you so that you can keep learning and improving on what you are writing. Which brings me to the second point that I did not mention before we started writing this query or the code that we are writing. So think about yourself as, let's just say a plumber, right? Now you see that a plumber would have a toolbox that they carry everywhere they go. Now in this toolbox there is everything they would ever need, but they are never sure what tool they will need when they are going to a client's house. Okay, now think about every skill or every code that you are going to be learning how to write right now as a tool in your toolbox. So every time we come from now on and you learn how to write a particular code, like today, we know at this point, we know how to retrieve data from a table. We know how to specify the columns. That's one tool in your toolbox. You have to keep adding this tool to your toolbox so that at any point, if anybody asks you to do something, you will now check your toolbox and now use the tools that you have to fix the operation. Okay, so you will continually need to be adding to the things that you have already learned. I've said it in a couple of classes that most of the things we are going to be doing are going to be building on things that we already know. All right, so we're going to move on. So now that we've known how to retrieve data from a table and specify the columns, let's go ahead and improve on that. Okay, we've done this. So the next thing we are going to talk about is what we call operators. Okay, now we need operators to be able to write concise Transact-SQL statements. Up till this time, we've been retrieving data, all the data in the table. That's what we've been retrieving, right? Most of the time, you wouldn't be asked to retrieve all the data in the table. Most of the time, you would need to retrieve just a subset of the data. Okay, so in the case of the production table, in the case of the product table, that we retrieved all the products with their list price and the sales price, the more normal question is to ask you to retrieve the product with sale price greater than 0. Okay, any product with a sale price of 0 is probably not useful data to anybody. Okay, it might be useful data to be able to know which products does not have sale price yet, but really you will be told to retrieve either the ones that have sale price greater than 0 or sale price that is equal to 0. In either case, you will see that you are not told to retrieve all the data in the table. You are told to retrieve just a subset of the data. Subset meaning that those ones that are greater than 0, right? Another subset could be those ones that are 0. Okay? So, to be able to achieve this, we need operators. And operators are simply symbols that can that specifies an action that is performed on one or more expression. Okay, we just saw an expression in the last example, and we said expressions are anything that evaluates to a value, right? So if you need to perform an action on one or more expression, you will need operators to be able to achieve this. And the categories of operators in the SQL Server products are what you are seeing right now. So you have arithmetic operators, assignment operators, bitwise operators, comparison operators, compound operators, logical operators, scope resolution operators, set operators, string concatenation operators, and unary operators. Now, in all these operators, we are going to deal with the ones that are most relevant to us as database developers, the ones that are common, like the arithmetic operators, like the assignment operators, like the comparison operator, the logical operator. Eventually, we will talk about the set operators, right? But that will be in subsequent class. But we will go through all the operators in the order that, in my experience, forms what is more common. Okay, so let's talk about the arithmetic operators. So the arithmetic operators are the ones that you are familiar with. They include the addition, the subtraction, your multiplication, your division, your modulo. Okay, the only one that can be a little bit cryptic to us here is the modulo. And what this does is it's you can see their symbols. Okay, they are used to run mathematical operation on two expressions of one or more data types. Okay, um, you know, they are mostly used for the numeric data type category, although the date time can also use addition and subtraction. Okay, so you can say you want to add 3 days to a particular day, or you want to subtract 3 days from a particular day. So the date, apart from the numeric data types, right, the date data types could also use addition and subtraction. But as I was saying, the modulo might be the one that is a little bit, off here. But the modulo is very simple. It just returns the remainder of a division between two numbers, right? So let's say you say 12 modulo 5, right? Normally, if you divide 12 by 5, it goes 2 times, right? And 2 times will be 10, remainder 2, right? So if you say 12 modulo 5, the answer to that is 2, right? So it's just the integer division that you get when you it's the remainder, the integer remainder you get when you divide one number by another. All right, so that's what the arithmetic operator is all about. Okay, let's look at some example. Right, so for arithmetic operators, let's say a somebody gives you a requirement that says that what is the total hour away from work for each employee in our database, right? What I want you to focus on right now is the operator itself. Don't really focus on the remainder of the code. We will get to this eventually, right? You will be able to explain. What I'm saying is you can see that there are some other statements that we have not actually covered, but that's not what I want you to focus on. I want you to focus on the operator itself. In this case, the arithmetic operator, the plus. So the requirement is to calculate the total hour away from work of each employee, right? And then to get the total hour away from work, you need to add the vacation hours with the sick leave hours. Okay, so in the human resources dot employee table, you have vacation hours in that table, and you also have sick leave hours. Now, the total hour away from work is an addition of the vacation hour and the sick leave hour. And so you can see how this is implemented. It's implemented as vacation hour plus sick leave hour, as we already know what the as keyword does, as total hours away. Okay? Now, and all the other arithmetic operators also function this way, right? So if you want to multiply, we saw that earlier on, you can use multiplication depending on what the business rule is. If the business rule says that total hour away from work is vacation hour plus sick leave hours, then you know that you need to use the plus arithmetic operator. If the business rule says that the total hour away is the vacation hour multiplied by 2, then all you need to do is to use the multiplication arithmetic operator. So just understand that any operator you are going to use will depend on what the business rule says it is. Okay, so let's look at another example, that the one that says return the remainder of product price into the number of product ordered. All right, so this wants the modulo of the product price divided by the product order. And look at what it does. Again, focus on the operator, right? What it does is it gets the unit price, which is the product price, right? And it divides it by the order quantity using a modulo. All right, so we if we execute this, we will get the integer remainder when the unit price is divided by the order quantity. Is there any question? Okay, if there are no question, let's just let's fire up Management Studio and let's fire up Management Studio and take a look at this really quickly, especially the arithmetic operator. Now, before we go there, before we go to Management Studio, now the arithmetic operator has the plus. Again, the arithmetic operator can be used, they can be used for numeric data types, right? Except the plus that can actually be used with the date time data types. However, the plus sign can also be a concatenation operator. When we say concatenate, what we mean is we are sticking two things side by side. That's what is called concatenation, right? We are sticking two or more things, but we are stacking them side by side. Okay? So, what I want you to understand is you can have the plus sign act as a string concatenation operator, or you can use it as an arithmetic operator. Most of the time, if you are dealing with numerics, then the plus sign will act as an arithmetic operator, in which case it will add one number to another for numerics. But if you are dealing with non-numerics like characters, strings, right? String of characters, then the plus sign acts as a concatenation operator. Okay, let's see what the difference is. So if we pull up Management Studio, let me take this off. If we pull up Management Studio and if we say select 10 modulo 5, you can see that this gives us 0, because if you divide 5 by 10, you will get no remainder. But if we say 13 modulo 5, you see that the remainder is 3. Okay, so that's just to show you the use of the arithmetic operator, the modulo. But if you now go to, let's say, what we were talking about in the example of the human resources employee table, if you look at the employee table, you will see that there is a vacation hour and the sick leave hour, right? So if we want to know what the total hours away is, right? The requirement is to show total hours away of each employee. All right, let's just assume that each employee is identified by a business entity ID. You can see that the primary key of the employee table is the business entity ID. So let's assume that for now, for what how we are, for the knowledge that we have now, let's assume that each entity is identified by a business entity ID. Okay, so if we want to know what the total hours away of each employee is, and the business rule says total hours away is the vacation hours added to the sick leave hours. All right, that's what the requirement says. So let's write that query. So we select as usual from, and then the table we are selecting from is in AdventureWorks 2017 dot. I showed you this trick last week where you can drag and replace and then place it in the query window. Now the columns we want is the business entity ID. I'm going to drag that onto the query window, and then we said comma separated. Remember, I want to see the vacation hours. I also want to see the sick leave hours. Then I'm going to write an expression that adds the vacation hours plus the sick leave hour. I'm using this. Now, if you look at, excuse me, I'm supposed to copy and not move. Now, if you hover over the sick leave hours, you will see that the data type is small int. Okay, so if you look at it in the column list also, you see that the vacation hour is small int and the sick leave hour is also small int. So in this case, our plus sign is acting as an arithmetic operator simply because we are adding two integer values. Integers are numeric values, right? So this plus sign here is acting as a as an arithmetic operator. Okay, so we said the addition of the vacation hours and the sick leave hour, we are going to alias it as total time away. Okay, all right, so let's run that and see what we get. Okay, so we can see that from our result set, we can see that for employee ID number 1 has a vacation hour of 99 and a sick leave hour of 69. His total time away is 168, and so on and so forth. Okay, so you can use arithmetic operators to be able to create expressions with numerics, right? But now when you are now talking about non-numerics, especially strings, character strings, right? Then the plus sign will now be a concatenation operator. Okay, and let's see how it does this. So if you are going to retrieve, so if you look at the person table, you will see that we have the first name and the last name in the person table, right? But you are told to retrieve the full name of everybody in your, so your task is to retrieve the full name of all individual in your database, right? That's your task. Okay, so everybody knows that the full name is made up of the um, the first name and the last name. Okay, so if you go ahead and you say select from AdventureWorks 2017 dot, all right, I drag my person, and you go ahead and you say, all right, let's select first name, comma, last name. All right, and if I run this right now, you would see that it selects it individually, first name, last name. That's not what your requirement says. Your requirement says retrieve the full name. Okay, so I don't want to see first name, last name. I want to see just one full name, which is the first name with the last name on the side. Okay, now in this case, we need the plus sign to be able to concatenate. Okay, we need the plus sign to be able to concatenate the first name and the last name. So because they are no longer numerics, if you look at the data type of the first name is nvarchar, which is character string. The last name is also nvarchar. So the plus sign here is not acting as an arithmetic operator, is acting as a string concatenation operator. All right, and then if we go ahead and say as full name. Okay, let's run this. So once we run this, we'll see that now we have a full name field of the first name and the last name. But then both of them are just squished together, right? People are not used to seeing full name as first name squished with last name. Okay, so what we can do is we can introduce a space in between the first name and the last name to make this more appealing to the eye and then look natural, the way people um, um, view names. Okay, so we see that the first name is right here. We have squished the first name with the last name right here. So in order to do that, we can also introduce another concatenation of a space, which is just made up of your quotation mark, space, another quotation mark, and just another string concatenation operator. So if you look at it the way it is right now, it's squished together, but we are trying to put in a space in the middle. And then what we did is we concatenated a space between the first name and the last name, such that if we now execute this, you'll see that this looks a little bit more appealing. Okay, and you can see how the plus sign acts as an arithmetic operator and also a string concatenation operator. All right, question. So let's talk about the where clause. Let's increase our vocabulary of the Transact-SQL language. Okay, so first you've seen the select clause in action, you've seen the from clause in action. Now we are introducing the where clause. The where clause, what it does is it introduces what we call search conditions, criteria, right? So remember I told you that it's not every time that you will be told to it's not every time you'll be told to retrieve every single record in a table. When I say record, I mean the rows. You're not going to be told to retrieve every single row in a table. Sometimes you are going to be told to retrieve just a subset of the rows in a table. When you are not retrieving every row in a table, you need to add a where clause. The where clause will restrict the query to satisfy the condition with which you are searching on. Okay, so anytime you want to retrieve a subset of the table rows and you are not restricting all the table rows, you use a where clause. So if they tell us to retrieve just the products that have sale price greater than 0, right, we need to introduce a where clause, because right now we are now being told to restrict the rows that are returned to only those that are greater than 0. All right, greater than 0 being the search condition. Any question on the where clause? All right, so when do you use where? You use the where to retrieve specific rows based on a search condition. So if you are going to restrict the rows that are coming back, you have to use the where clause. All right, the search condition in the where clause can contain an unlimited set of predicates. We'll talk about that, right? And then if you are going to use the where clause, remember the single quotation mark. If it's not a numeric data type, the rule is you place it in 2 single quotation mark. So if it's not a numeric data type, just know that it's a syntax rule that you would use 2 quotation mark to bound it. We saw that last week. Okay, so we call the where clause a filtering clause. We are using it to filter. Okay, and when we filter, how do we filter? Right, we filter by limiting the results that the query will return. Okay, and if we are going to use filters, we will need to use the following type of operators. Remember, we introduced operators in a few minutes ago, but now when we are talking about filtering data, when we are talking about using the where clause, right, we need to use these specific types of filter. Now, the first filter is the comparison operator, and the comparison operator are the equal to, greater than, less than, greater than or equal to, less than or equal to, or not equal to. Okay, now the prior example I was given, when I said return products that are that have sale price greater than 0, you can see that in that case you would have to use a comparison operator in conjunction with your where clause. Okay, we will see the use of all these types of filter as we go on in this class. Okay, but just know that the where clause is used in conjunction with any of these operators that you have here to be able to restrict the results that are returned by your query. Okay, so first let's talk about comparison operator. The comparison operator just compares values in a table to a specified expression. So if we say return products that have sale price equal to 0, okay, that's a comparison operator, right? Maybe before we talk about that, we should know what comparison operators are. The comparison operators are the equal to, the greater than, the less than, greater than or equal to, the less than or equal to, or the not equal to. Okay, the not equal to can be written this way, or some people actually write it this way. It means the same thing. So it's either this way or this, or people write it like this. So there's an exclamation point. There's an exclamation point. Huh. How come I can't put in a dot? But just assume there's an exclamation point followed by an equal to sign. Alright? Some people write not equal as that. So these are the comparison operators. Let's quickly see how these comparison operators work, and then we can call it a day. Alright, let's go back to Management Studio. Alright, so let's see how our comparison operators, let's see how they work. So in this case, you are told to retrieve the customer You are told to retrieve the customer who has a customer ID of 5. Immediately, you realize that this question is not asking you to retrieve every customer. Okay, that means that it wants to restrict the data that comes back. And whenever you want to restrict data that comes back, then you have to introduce the where clause. Okay, so you guys know how to retrieve data from the customer table by what I've highlighted. If I execute this, it will retrieve all the customer, right? If I execute only the select and the from, it will retrieve all the customers, the 847 of them. But that's not what the requirement tells us. The requirement tells us that retrieve only the customer with the customer ID of 5, right? In that way, we know that we have to introduce a where clause because we need to restrict the rows that comes back. All right, so we introduce the where clause, and then we need to write a comparison operator because we want the customer ID. Okay, so we write the customer ID, and we are comparing that customer ID with the comparison operator of 5. All right, so it will be where customer ID predicate equals to operator 5, the expression that we want it to equal to, right? So we are now restricting the values or the rows returned. We are restricting it to only the customer ID of 5. All right, so with the where clause, we are able to restrict our data set or the result set to just this customer ID of 5, which is Lucy Harrington. Okay, so to restrict the rows returned, you would use the where clause. All right, and then we are now talking about comparison operator. The requirement says only those for customer ID of 5. Okay, so in that case, we need a comparison operator. What if the requirement tells us to return the customer with the last name of Guy? Okay, remember we said if it's a numeric, you don't need to bound it. But if the field that you are using as your predicate, in this case the last name, is a non-numeric, like a character data type, then you need to bound the value by two single quotation mark. So in this case, we are told to retrieve the row for the customer with last name of Guy. All right, so we introduce our where clause, last name equals to G, and if we execute that, we see that there are two rows that satisfy that particular query. So instead of retrieving all the customers in the customer table, we are just restricting it to those that have the customer last name of Guy. All right, so you see that your where clause restricts your result sets to just the ones satisfying the criteria that is listed above. Also note that the order is your select comes first, followed by your from, then the where clause. Okay, now if you are told to retrieve the address with a country region of Canada, okay, you do all your design, and then you know that you need address line 1, the city, the state, province. You don't need all the address in the address table. You need only for those with the country region of Canada. Okay, so now you know that you need to write a where clause, where country region, and then comparison operator Canada. Because country region is not a numeric data type, you need to bound the value in two single quotation mark. If you run that, you get address, city, and all the result that is going to be returned is going to be the ones with country region of Canada. If you want to satisfy your own curiosity, you can add the country region as a field to be returned. And if you now run it again, you will see that everything returned in country region is going to be Canada. Okay, so just note that the where clause restricts. The where clause restricts. So we've seen the equal to comparison operator. Let's see another comparison operator, right? If you were told to return the sales order ID and the customer ID from the sales order table with order dates that is prior to this date, okay? If you are talking about date time, right? Any date that is prior is less than. Any date that is post to the date you're talking about is greater than. All right, so in this case, we want the sales order ID and the customer ID of an order date that is prior to February 23rd, 2015. So you return as usual your sales order ID and your customer ID in the select list. You tell us where it's coming from, and you now issue your where clause because we want the order date prior to this date. So order date, where order date is less than the February date. And if you issue this command, execute, you will see that all these sales order ID, customer ID that is returned, the 32 of them have dates, order dates prior to 02/23/2015. Again, just for a sanity check, you can include the order dates in your select list and then run the select. And if you look at 2008, right, 2008 is prior to 2015. Okay, you can see that everything that is returned is prior to this date. Any question?